we come now to a description of Newton's laws, known as Newton's three laws of motion. And yet, you'll notice right at the outset, I'm highlighting Galileo. Galileo Galilei. There's the era of time he was around, because he's the one that really came up with the thinking, the idea behind this. He maintained that motion would maintain itself unless there was a cause of acceleration or a cause of retardation. And yes, that is his word. And if there was no cause, then there'd be no change in motion. The motion would maintain itself unless there's this mysterious cause. So in this graphic, you see a marble rolling down a ramp. There's a cause of acceleration, a force to move it down the ramp upward. It would slow down because there's a cause of retardation. But on a flat surface, there would be no cause. It would maintain its motion. So this looks simplistic, but he did really in-depth analysis in these experiments. Galileo, by the way, was a non-respecter of authority. He was not a very necessarily, politically correct type of person. He just said things as they were and needed experimental data. Experimentation would validate theories, not just philosophy such as Aristotle perhaps would have been motivated by. But anyway, his law of inertia, often called Newton's first law, Galileo's law of inertia. It's this idea of the concept of inertia, that every body continues in its state of motion, and that state of motion can be at rest or at a constant speed in a straight line, unless acted on by
a net unbalanced force.
And if there is a net unbalanced force, then there is a cause for the acceleration or the retardation. So, just exactly what does it mean for an object to have an unbalanced force acting on it? If it's unbalanced, well, of course, it means it's not balanced. So that typically entails in practical situations that all the friction is overcome by the force. Once all the friction is taken care of, then it will increase speed in the direction of the net force. So net force means that the forces are unbalanced. You've overcome friction, and now you've got additional force to cause it to change its motion. Friction isn't the only thing, but it's a typical example. Now, would this still be true if the force was infinitesimally small or the mass was incomprehensibly large? The old saying, if the immovable object meets the irresistible force, who's the winner? Well, it sounds like a real gotcha, but there is a resolution to this paradox. It's a false contradiction. Has a resolution, namely in the terms that you're using. Because the reality is that a change in speed will always occur if the force is indeed unbalanced. So a couple simple examples. There's a physics book sitting on a table. Gravity pulls downward on the book. The table pushes upward on the book. Those two forces are in balance, so there's no change in motion, namely the state of rest that it finds itself in. Another example, here we got a truck moving down the road. We have a resistive force of 60 newtons, but that's smaller than the larger thrust force of 100 newtons trying to propel the truck along. And so the truck speeds up in this direction. It is actually unbalanced there. Let's use another somewhat strange example in the extreme here. Jupiter and all of its mass tied like a little gift, and here we have a flea hooked on to the end of this thing, and somehow the flea is going to find some traction and give Jupiter a pull. The idea being that Jupiter is hovering in space where friction is completely removed, if this flea, which of course would not be visible at this scale, could get a grip on something and pull, then it literally could change the motion of Jupiter, even though it would be very, very, very small. If that force is unbalanced, the motion of Jupiter will change, as will anything change. You could move a mountain. If you hooked a big rope around a mountain and pulled strong enough to overcome the forces of cohesion between the atoms as it's structurally, held together. If you could break that loose, somehow put the mountain on a frictionless cushion of air or something, you could pull the mountain around with you. So that would be a lot of fun, but hopefully that makes the point.